All right, so 2.4, that's the 2.4, that's the what? The operations and functions, okay? So what do you mean operations? So operation means this the plus, minus, multiplication, and division. These are these are called the four basic operations or operators. Okay. So normally yeah, definitely we use these four operator between numbers, right? So for example, 2 plus 4, yeah, this is 6, right? Okay. But we wanna then, so here in this section, we wanna um, define the operators can be used between functions that are similar to these four basic operators. Okay, so for example, the f of x plus g of x. Okay, what does it look like? Okay, so I know actually this is the definition of um, the sum functions. Okay, so anyway, so the goal in this section is to define the kind of new operators. Okay, so resemble to four basic operator plus, minus, multiplication, division can be used between functions. Okay? And then also we're gonna see the one more the operator, which is not like the four basic operators. Okay, so that actually that's the main objective in this section. But all right, so I'll talk about this one later. So objective. So first one is this. Let's see. Yeah, I just first one some functions. Okay, so what do we mean some function? Some function means this f denoted by f plus g of x. Okay, so f plus g is key is f g two letter represent functions. Okay, so f plus g that some function is defined by just f of x plus g of x. Okay, so I know it's a little bit abstract, right? So let me give you an example. So let's say f of x is the square root of x and then g of x. Okay, is defined by maybe just I don't know x over 2. Okay, so then the sum function of f plus g of x is going to be square root of x plus x over 2. Okay, so I know, so it's just kind of straightforward, right? So just adding two functions, that's the definition of some functions. Um, but the problems in this section not only ask you to find out some functions, but also probably ask you to find out the domain of that some functions. Okay, so then what? We know the domain of square root of x is 0 to infinity, right? And then domain of x over 2 is negative infinity, infinity. But then what? What about domain of the sum functions? See that square root of x plus x over 2. So even though, second term, when you look at the second term, that comes from the g of x. So the domain of the second term must be negative infinity, infinity. But what? The first term, that comes from the f of x, and domain of the square root of x is 0 to infinity. Then we have to choose the intersection of two domain of f and g, which is 0 to infinity. Okay, so it's negative infinity to infinity. Okay, so negative infinity to infinity is the domain of g of x, right? Because x over 2 is nothing but half, 1/2 times x, which is polynomial. So please keep in mind this. The domain of any polynomial function is negative infinity to infinity. Okay, so but domain of square root of x is 0 to infinity. These are the color. So 0 to infinity. Okay. Right. So now, yeah, so this is 0 to infinity. So what's the intersection of two number? 0 to infinity, right? Because 0 to infinity is belong to negative infinity, infinity, right? Okay. So, so you are not, necessarily to find out the domain of f and g in the tag intersection to find out domain of some function. Okay, but this is one way. Okay, the other way is this. Just look at the equation of the some functions and then try to find out domain. Okay, directly. Okay, so c square root of x over 2, what? Even though x can be x can be a negative number right there in second term. When you look at the square root of x cannot be a negative number because square root of negative number is a complex number. Okay. So here the domain is what? Is a negative, 0 to infinity. Okay. And that's the domain of f plus g, some functions. So two things in this objective. The first one, the definition of some functions. Okay. Yeah, it's just really straightforward, right? So I don't think it's hard to understand that one. Okay. So next one is, guess what? It's in the minus right here. That's the difference function. Okay. Difference function. So difference function definition. First one, the notation is this: f minus g of x. This is equal to f of x minus g of x. Okay. So example. So f of x is defined by, well, just 2x squared. Okay. And the g of x is defined by f of x. Okay. And then f minus g, which is difference function of f and g, is gonna be 2x squared minus absolute of x. Okay. Then let's find out domain. Domain of, difference function is, guess what? Negative infinity to infinity, right? Because z to x squared is a polynomial. I told you the domain of polynomial is from negative infinity to infinity. And then domain of absolute is also negative infinity to infinity. Okay. So domain is what? Negative infinity to infinity. Okay. And then third one is the sum difference. And next one, you see that? The multiplication is product function. Oops. Okay. So f times g of x. Now then is what? Guess what? Just f of x times g of x. Okay. So example is this. Let's say f of x is defined by 2 times square root of x, and then g of x is defined by x plus 1 square. Okay. Okay. So it now you should know how to plot the graph of 2 times square root of x and the x plus 1 square using transformation. Okay, because we learned that transformation 2.3, right? Okay, so then f times g of x is going to be 2 times square root of x times x plus 1 square. I don't think we can simplify more. Okay, so that's it. So then what about the domain? So yeah, just find the domains is for the product function is yeah, this really just similar to excuse me, what we did in difference functions, some functions. Okay, so see x plus 1 square, just polynomial, so domain is negative infinity, but you see the 2 times square root of x, so the square function, so domain must be what? 0 to infinity. So this domain of the, oops, okay, the domain is what, 0 to infinity. Okay, so when you look at this, excuse me, look at the sum function, difference function, product functions. So in the look, I mean the only look at the only example. So see, f of x is square root function, g of x is polynomial function. So the what? If two functions are combined with a new operator, you know, sum and difference and product, and then we're gonna see a quotient. Anyway, so two functions are combined with the new operators, and then they are different type of functions. You see a square root function in the polynomial. This is a polynomial absolute value. This is square root and the polynomial. So two distinct types of the functions are combined with a new operator. Right? In that case, when you find out domain, you need to find out intersection of two domains. Okay, so keep in mind this. So for the 1, 2, 3, so what I did to find a domain, I found the domain of f and g. Okay, and then I took the intersection, right? So, or I told you already. So you just yeah. So you don't if you don't want to find out the domain of f and g, just look at the the equation of the f times g. Okay, so just you can figure out the domain of that function. So see here, this even though this x in this here can be any real number, but the x under the square root can be only positive number. I mean, non-negative number. Okay. So now the last one, not last one. The next one is quotient rule or quotient function. So f over g of x. This is f of x. Guess what? Over g of x. So divide the f of x by g of x. Okay. So, but yeah, it's the example. The f of x is to say 2 times square root of x, and the g of x, let's say I don't know, maybe f square root of x. Okay. So the figuring out the equation of the quotient function is not a big deal. Okay. You just divide the f by g. Okay. But the thing is this: what about domain? So when you find a domain, since just look at this, g of x is in the denominator. So we need to find out the x where g of x equals 0. Okay. So that x value makes denominator 0. So we have to exclude that number from the domain of f of x. And domain of f of x, yes. Okay. So actually intersection of domain of f and g. Sorry. So now let's see example. Yeah, let's find the domain of f quotient functions of that example and equation of quotient function. Okay, so let me copy this example. 2 times square root of x, square root of x. Okay. Yeah. So now the f over g of x is going to be 2 times square root of x over f squared of x, right? Okay. So then domain of f, the f of x is what? 0 to infinity, right? Oops, infinity. The domain of g of x is going to be what? Negative infinity, infinity. Okay. So then intersection of, 0 to infinity intersected with negative infinity, infinity is what? 0 to infinity. But I told you this is not a what? That's not a domain of quotient function. So why? Because you see that when you look at the denominator, when x equals 0, we're gonna get big trouble. Why? Because you know the 0 I mean, something over the zero is not defined in mathematics, okay? So we have to exclude zero from the intersection of f and g. So the domain of f over g of x is going to be is what? Just open 0 to infinity. Okay. All right. Now, next one is 4, 2, 3, 4, and the 5. But the composition. Yeah, this is quite complicated. Okay, and then just actually main objective of 2.4. Okay, composition of function. Definition is this. I mean, first notation f circle g. Okay, this is not dot. Okay, this is a little circle. Okay, but this one we read this one as f. Oops, after g. Okay, f after g. Well, that depends on textbook, but the our textbook suggests that to read this notation, the composition as f after g. Okay, but other textbook just suggests that read it as f circle g. Okay, f circle g, f after g. Okay, so definition is this: this is equal to f of g of x. Okay, so what does that mean? F of g of x. It means that we use the g of x as input of f. Actually, g is a what? Output of g, right? I mean, g of x means output of g. I mean, y value of g, right? But anyway, so we use output of function g as input of function f. Okay, keep in mind this. Then in that, definition of composition, that we can figure out that, g circle f, I mean, g after f is different from the f after g, right? It's going to be g of f of x, right? It means that we use output of f as input of g. So these two guys are totally different, right? So to distinguish f, the order of f and g, I think the textbook used that one, f after g. Okay, so but here this one is g after f, right? Okay. So anyway, this is the example. By the way, in general, I told you in general, but f after g is not equal to g after f. Okay, keep in mind this. So this example. So let's say f of x is defined by 2 times square root of x. Okay, and then let's say g of x defined by x squared. Okay, then f after g of x is going to be f of g of x, right? So now we're going to plug in equation of g x squared into here. Okay, I mean replace. Okay, so replacing g, okay, by x squared, we got f of x squared. Okay, now here see that x squared, that's going to be what? New first coordinate in the function f, right? So we replace x. Okay, not only just in this case we got only one single x, right? But you have to replace every single x on the right hand side of function f by x squared. So that's going to be 2 times square root of x squared, which is 2 times x, right? Okay, so now what are you going to do? I mean, what about the domain, by the way? So domain of 2x is what? In this case, don't try to find out the domain of the composition f and g from the domain of f and g, okay? That makes you really confused. So just try to find the domain of f circle g, I mean f composition f and g by just look at this. Okay, 2x. This is a polynomial, right? I told you the domain of any polynomial is what? Negative infinity, infinity. Okay, so domain of f circle g. Sorry, I just keep saying f circle g because yeah. So but this textbook uses f after g. Okay, so please understand that sometimes I just read the composition as f after g or f circle g, but yeah, they are coined. Okay, so this one is negative infinity, infinity. Okay. But anyway, so what about the g after f? Okay, so don't assume that. Okay, g after f. Don't assume that g after f is equal to f after g. Some a certain under the certain condition, two composition gonna be identical, but in general, no. Okay, it's not. So this is g of f of x. This is equal to g of what? 2 times square root of x. This is equal to 2 times square root of x square. Okay. So what is f? F is 2 times square root of x, right? So, and then g over 2 times square root of x. Now 2 times square root of x becomes what? The new first coordinate. 2 times square root of x is represent the first coordinate of function g. So we replace x. You see that here, right? X right there. Replace x by 2 times x square root of x. So we got this, which is what? 4 times x, right? Okay. Yeah, so 4 times x. Okay, so domain is what? Negative infinity, infinity, right? So also, see, we got the 4x, but here we got 2x. So see, I told you, f after g is not equal to g after f in general, okay? So now we're gonna see examples of each, objective, okay, in the textbook. Okay, I'm gonna go over that. Give me a second. All right, so let's see example 2 first, okay? So in this example, the two functions are given by not equation, but you see the set of order pair, right? So then how can you find out the sum functions and, you know, in this case, sum functions and what product function and quotient function? Okay, let's figure out that. So f plus 3, just give me a second. So example 2, so set f is 1, 3, the 2, 8, 3, 6, and 5, 9. Okay, and the g defined by 1, 6, 2, 11, 3, 0, and 4, 1. Okay. All right. So now then, f plus g of x, a. This is f of x plus g of x, right? Okay. But look at this. Since the functions are not given by the equations, so the what we got just finite number of the x coordinate in the domain, right? So for the function f, we have got 1, 2, 3, 4, 5, and the for function g, we got 1, 2, 3, 4, right? So we only just evaluate the sum functions at x equals what? 1, 2, 3, and 4, 5, right? Okay. So let's see, f plus g of 1, okay, and then f plus g of 2, and then f plus g of 3, okay, and then f plus, you can say f plus g of 4, but you see that f plus g of 4, now think about this, f plus g of 4 means what? F of 4 plus g of 4, but g of 4 is defined, which is 1, right? But what about f of 4? Since 4 is not what in the domain of function f. So this is f of 4 is not defined. It means it does not exist. Okay. So in that case, we say DNE. DNE means that does not exist. You may see this abbreviation in the online homework. Okay. So but then you that means does not exist. So f of 4 does not exist. Okay. Then so that what? F plus g of 4 does not exist. Okay. Same goes the sum function with x equals 5. Okay. So this is f of 5 plus g of 5, right? But yeah, we see the f of 5, which is 9, right? F of 5 is 9, right? But what about g of 5? Because 5 is not in the domain of g. So g of 5 is DNE. It does not exist. So it means that this is DNE. Okay. So now we can see that what the domain of f plus g, some function is just 1, 2, 3, right? You can see that. Okay. So now we figure out the rest of them. So this is f of 1 plus g of 1, okay, which is 3, and then plus 6, which is 9. Okay. The f plus g of 2 is what? F of 2 plus g of 2, which is f of 2 is 8, and then g of 2 is 11, right? And f of 3 plus g of 3, so which is 6 plus 0. This is 0, I mean 6, this is 19. Okay. Okay. So now we see that. Okay. Then what about the f over g? Okay. So f over g. Okay. So now then f over g is what? This is x. Okay. Is equal to f of x. Oops. F of x over g of x. Okay. Then yeah. So yeah, let's try to figure out this quotient function for each x value. I mean 1, 2, 3, 4, 5. I don't think we can figure out the quotient function at x equals 4 and 5, because see, even though g of 4 is defined as 1, but f of 4 is not defined. And then even though f of 5 is defined as 9, but g of 5 is not defined. So we just drop the 4 and 5. Okay. So now we figure out the what f or f of quotient function of f and g at 1 and 2 and 3. Okay. But see, what about this f over quotient function of f and g at 3? This is f of 3 over g of 3. F of 3 is 6, g of 3 is what? 0. Because g of 3 is 0, right? Okay, see that g of 3 is 0. So that is what? Does not exist. Okay, does not exist. So now then, what domain of the quotient function is not 1, 2, 3. I mean set of 1 and 2, 3, but just 1 and 3. Okay. So then this f of the quotient function f of g at 1 is going to be 3 over 6, which is 1/2. And then quotient function of f and g at x equals 2 is 8 over 11. Okay. All right. So now, what's the answer to look like? For this one is equal to what? The set of what? 1, 1/2, and then 2, 8 over 11. Okay. So what about the but this one here, back to here, this is the set of what? 1, 9, and 2, 19, and then 3, 6. Okay. So that's the answer. This is the answer. This is the answer. Okay. Now we move to the example 3. Oh no, not this one. G over F. See example 4. Okay. So example 4. Yep. Example 4. So this one also two functions. I show you. Yeah, so let me just copy it. Okay, so let's say function g is given by a set of order pair. So 1, 4. Okay, let me just copy it. Okay, and then I'll just fix the autofocusing. Okay, and f is just 3, 8, 4, 9, and 5, 10. Okay, so question is to find the app circle G. Okay, yep. Second, still growing. All right, so now see two functions are given as set of the pair, and then we find the app circle G. Okay, so now what are you gonna do? We start from the app circle G of x. This is f of g of x. We start from the definition of the composition, right? So now we need to figure out what value, what number we have to plug in into x. Okay, so this x is what actually what should be what the number in the domain of g, right? So this is the domain of. We have to choose the x value from the domain of function g. Okay, g of x. Okay, so now see the domain in the domain of function g. There is what 1, 2, 3. Okay, you see that 1, 2, 3. So 1, 2, 3. For example, let's say here's a 1 and 2 and 3. So that's the domain. Let me say just domain of function g of x. Okay. So now we evaluate function g at x is 1, 2, 3. Okay. So now then, let me write down right here. Okay. So I mean, what this is equal to f after g of 1, f after g of 2, okay, and f after g of 3. Okay. So let's see. Keep in mind this, these numbers from the domain of function g. Okay. So f of g of 1, the f of g of 2, and the f of g of 3. Okay. So what is g of 1? G of 1 is 4, right? So this is f of 4. This is f of 1. G of 2 is 5. Okay. And then g of 3 is what? 6. Okay. So 1 goes 4, and then 2 goes 5, and then 3 goes 6. But here's the problems. So now we evaluate f at 4, 5, 6. Okay, then to do that, what we need to check that whether or not these numbers 4, 5, 6 are in the domain of f. What's the domain of f? 3, 4, 5, right? So 3, 4, 5 right there. So here's 3 right here. Okay. So you see that 6 and 3 are out of. I mean, 6 is what? Is out of the domain of. That's the domain of what? F of x. Okay. So let me use other color. That's the domain of the f of x. Okay. This is the what 3, 4, 5, 6 is what actually 4, 5, 6 is what the domain of range of g of x, right? So it's this right here. So this is the range of g of x. Okay. Right here. Okay. So since by the way, the 6 is the out of the what out of the domain of f of x. So this is d and e. Okay. So we drop this one. Okay. This does not exist. Right. So what is f of 4? is 9. What's f of 5? 10. Okay, you see that 4, 9, 5, 10. Okay, so 4 goes what? 9, and then 5 goes 10. Okay, yeah, definitely there is a, yeah, 8 right there. So this is the what? That's the range of f of x, right? Okay, let me use other color. This one, range of f of x, right? But actually, we got not all of them, but just 9 and 10. Okay, so 9, 10 right here. 9, 10. Okay, so range of f of x, 9, 10 is what? That's the what range of, okay, range of f after g of x. Okay. Oh, okay, here's a question. What about the domain of f after g? What's the domain of a composition of f and g? Just 1 to 3? No. You see that? When x equals 3, eventually we got what? dne, right? When you plug in 3 into the composition f and g, we just eventually we got dne. So 1, 2 is the what? Are the what? Only the numbers in the domain of f, composition of f and g. Okay, so domain gonna be what? 1 and 2. Okay, that's the domain of f after g of x. Okay, so here. Okay, right. So then, is there any kind of pattern or rule for finding the domain of f after g, composition of f and g? Maybe, but totally depends on problems. Okay, so the for both cases, functions are given by the set of ordered pair like this, or given by the equation. For both cases, when you find the domain of a composition, yeah, just um, don't try to figure out the pattern, or don't try to find the domain of f and g and then just take an intersection or union. You don't have to do that. Don't try to do that. Okay, just find out, just evaluate composition. Okay, evaluate the composition of f and g at every at I mean the each numbers in the domain of g. Okay, like what I did like this, and then if you got dne, then just take out that number from the domain. Okay, so I think that's the best way. Okay, for the I told you, so what if the functions, let me see, is functions are given by equation like this, then you just, yeah, no, don't try, I told you, don't try to find the domain of f and g in the take intersection. Okay, no. Sometimes work, but that totally depends on problems. Okay, so you once you get the composition and then try to figure out domain of the result equation of the composition. Okay, so now let's see. Give me a second. Religion. Come in here. Now this. Okay. So let's see more problems. Okay. Example 5 and the color day. Okay. So because I need to the I need to cover the section what I covered with the other section of the closed algebra class. Okay. So the example 5. So we'll see this f of x is defined by square root of x, and then g of x defined by 2x minus 1. Okay. So let's find out f after g of not x but 5. Okay, and then a, and then b. This is g after f of 5. Okay, so in this case, you don't have to figure out the equation of composition of f and g and f. Okay, you have to do this. So and then look at these problems, and then see the instead of x, a specific number is the given. Don't try to find out composition equation of the composition of f and g and f. Okay, just apply the definition of composition, which is f of g of 5, and then we figure out the g of 5. Okay, it means they evaluate g at x is 5, which is what? 5 times 2 times 5 minus 1, which is 9, right? So this is f of 9. That's square root of 9, right? Which is the base. So for this one is g of f of 5, which is what? G of f of 5 is what? Square root of 5, right? And then we got 2 times square root of 5 minus 1. Okay. I mean, see the total difference. We see that, f after g is not equal to g after f. Okay. So let me stop here. I'm going to continue to look at the 2.4, and then we'll see online home problems next week. Okay. So let's take roll and then just call it a day.